Greetings and welcome, internet friends. Today we're going to learn our last method for solving quadratic equations using the quadratic formula. And so here in Exploration 1 is a derivation, the origin story of the quadratic formula. So check this out. Explain what was done in each step. And so here is a quadratic equation. One could say given was the first step. Let's see. There we go. And so what happened between step 1 and step 2? Well, looks like div by a. Oh man, my my tablet is writing wonky. That's all right. Subtract c over a from both sides is what happened here. Then what? Let's see. It looks like this is related to this. Complete the square. Complete the square. Right, and so we found the new c term using right, c is equal to b over 2 all squared, and in our case, b was the following, b over a, and so b over a divided by 2, I tried to not have a stack-o-frac situation going there, so I just wrote it as b over 2a, and then I squared top and bottom, and got this, and then added that to both sides. Okay? Good. And so you're not going to be expected to derive this on your own, just want you to know where this comes from. And so look for the forest through the trees sort of thing. All right, from here to here, we factored. This is a perfect square trinomial because we completed the square. And so it looks like we factored. And on this side, what happened? Well, we had negative c over a plus b squared over 4a squared. It looks like I found a common denominator. All right, so common denom. Boom. Let's see. On the right side, we added these two fractions. And notice I did the b squared minus 4ac. I wrote that up top. And I could have technically written negative 4ac plus b squared in the numerator. It's the same difference. But this will become a familiar pattern expression to us right here. So that's why I wrote it in that order. So add fractions. Add fracs. Root both sides is what happened next. And then when I root this side, the square and the square root cancel out. Notice also when I root both sides, I have to remember plus or minus. That's the classic. And then here on the right side, it looks like I distributed root over fraction. Right, and so the numerator is now squared. The denominator square rooted. The denominator when I square rooted, square root of 4 became 2. The square root of a squared became a. And then looks like to go from here to here, subtract b over 2a from both sides, and then because these two fractions have the same denominator, I'll just say add frac. Boom. And so why is this significant? Why is this helpful? Well, using the values of a, b, and c, we were able to get x by itself. We were able to solve for x. And notice the right-hand side, however crazy this thing looks, it is made up of only a's, b's, and c's, as well as some numbers and exponents and things like that. And since a, b, and c's are numbers themselves, that means if I just plug in the a, b, and c into this equation, I will solve for x. And now remember, many of our quadratics have two solutions. And where does the two solutions show up from this? they show up right here from the plus or minus piece right there. And so this is a derivation of the quadratic formula. Quadratic formula. And so that's what this lesson is going to be all about. And so the formula for solving quadratic equations is this. And oh, by the way, it is commonly associated with the song, the tune of Pop Goes the Weasel, which I had to sing on my very first teaching job interview, oddly enough, in front of a class of students I'd never met, a principal, an assistant principal, the math department head, and the teacher that I was covering their class for. So it was an interesting day, and I felt awkward having to sing. But now, after 1,000 videos on the internet, I think I'm going to be, I'm going to sing it. Here we go. Ready? Pop Goes the Weasel. X equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. There we go. And so that's the quadratic formula. A couple little facts about it here. The denominator can't be 0, and inside the radical can't be negative, because otherwise you get imaginary. But although my Algebra 2 students, at least this semester when I taught the course, I've already taught them about imaginary numbers, and so maybe it can? All right, well, let's put this to work. So, first thing, to use the quadratic formula, I've got to get my quadratic equation in standard form, and so I've got squared x constant equal to 0. Identify a, b, and c. So a is 2, b is -5, and c is 3. And now I plug it into the formula. And so here we go. Ready? X equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. And so notice I just plug in the a's, b's, and c's everywhere they go. And now it's just kind of, it's plug and chug. There's not even any algebra from this point on. It's just order of operations. I'm going to PEMDAS this problem. And so let's do that and have a calculator ready, because oftentimes I'm going to be using the quadratic formula for problems that are not factorable, problems that will have decimally sorts of answers as approximations. So the opposite of -5 is 5, plus or minus the square root. -5 all squared is positive 25. -4 times 2 is 8, times 3, 24. All over 2 times 2 is 4, equals 5 plus or minus the square root of 1, all over 4, equals 5 plus or minus, well, the square root of 1 is 1, all over 4. And so final answers, I get x equals 5 plus 1 is 6, so 6/4, right? Which is equal to 3/2. There's one answer. And x equals 5 minus 1 is 4/4, which is equal to 1. And so I get my two answers. Voila. And so notice just at the end here, I split it. I guess I'll use this color. I split this. All right. And I started working up here. Yeah. All right. That's fine. And so, yeah, you do the plus version, you do the minus version. Good. And so 1.5 and 1 are the solutions of this quadratic. Let's see. Let's take a gander at this one. This one's a little ugly. I'll do the quick setup. Actually, I could, option 1 is I could say a equals 1/2, b equals 1, c equals -10. But watch this trick. Let me just get rid of the fraction multiplying everybody by 2. I would have gotten x squared plus 2x minus 20 equals, and 2 times 0 is still 0. This is much friendlier numbers for a, b, and c. And by the way, you can kill all the fractions in an equation typically by multiplying by the least common denominator of all of them. Yeah, they fall apart from the insides. You destroy them somewhat like by attacking their genetic makeup with denominators. And so let's plug this in. So x equals the, all right, you guys were going to request the song in chat, so I might as well. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so yeah, then I would just simplify from here. I don't think I'll do this whole problem. Often students make mistakes with sign errors and, not squaring negatives correctly. Often students make mistakes here with like, kind of how you got to keep track of all of this multiplication and negatives. So here 2 squared is 4. Negative 4 times 1 is negative 4 times a negative 20 is positive 80. All over 2 times 1 is 2. Sometimes students make mistakes by the all over 2a. They might only have written their fraction bar underneath this part. Another mistake that students sometimes make is trying to distribute the square root to each of these pieces. Super illegal. You can't distribute square roots over addition. All right, and so lots of possible ways to make mistakes, but as long as you're obeying the laws of math, you will be fine. And so square root of 84, I think technically I can, what could I break into that? Is 16? Does 16 go into it? I don't feel like it does. 84 divided by 16. No, but 84 is divisible by 4. So I could have broken that up into square root of 4 times square root of 21 all over 2. And so final answers, plural, right? Negative 2 plus or minus 2 square roots of 21 over 2. Man, I thought it was going to be my final answer. But then I realized at the very end here that the 2 parts in the numerator are divisible by the denominator. All right, here we go. Final answer. All of these can be divided by 2. So negative 1 plus or minus the square root of 21. And so this is a quadratic equation which never would have been solved by factoring. You could have solved this by completing the square. It would have brought you to the same exact solution. But yeah, quadratic formula, it's a thing. It technically requires less algebra, right? Completing the square requires a lot of skill with, little formulas and factoring and root both sides. And yeah, good stuff. Tell you what, I'll just do the setup for this one. I would have, got to make sure it's set equal to 0. So I would have added 1 to both sides. And then a is 4, b is negative 4, c is 1. Okay. Also, by the way, on this, you could get decimal approximations, I imagine, sometimes. Sus libro will ask you to. All right. Ooh, the number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function. Blah. All right, cool. And so, years since 1990. So what does 18 represent? Well, that would represent the year. Oh, wow, Waddy. I almost said 2018. Ha! But it's since 1990, not 2000. So it's 2008, right? Would be what, right? That's the same as 2008. And so all I'd have to, if I wanted to calculate, when X is 30, for instance, that would represent 2020, the year that I presently reside in, if this model happened to continue. And so here's an equation that represents that function even. And then they said, when were there about 35 breeding pairs? So the number of breeding pairs is the y-axis. And so I could just plug 35 in for y. And so let's do that. So 0.2x squared plus 1.8x. Oh, this is good. I'll show you how to deal with decimals as well. Equals 35. So in order to use the quadratic formula, I'm going to have to subtract 35 from both sides. 0.2x squared plus 1.8x. minus 38 equals 0. And tell you what, in order to get rid of decimals, whatever number of digits are after the decimal, you can multiply by some multiple power of 10. So multiplying by 10 will shift it over one place. 100 would shift it 2. 1,000 would shift it 3. But if I multiply both sides by 10, check this out. I can get 2x squared plus 18x minus 380 equals 0. And now, for using my A's, B's, and C's, these are friendlier numbers. I mean, yeah, 380 is starting to get grande, but it is okay. Dear, I might not have enough room. X equals the... All right, here we go. Let's sing it again. Let's keep singing it. That way you'll remember it. It's true. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And so X equals negative 18 plus or minus. If you're talented, you could start doing all that move in a calculator. Actually, I'm running out of space, so I'm gonna. 18 squared, nope, automatic typo. Now notice, let's see, I've got two negatives being multiplied, so the final result of that product is positive. So 4 times 2 times 3, 8, 0. So I'm getting the square root of 3364 all over 2 times 2 is 4, equals. I'm just going to take the calculator's approximation of 3364. Oh, wow, it happens to be exactly 58. Negative 18 plus or minus 58 divided by 4. And so final answers, I'll write them up here. X equals, now negative 18 plus 58 is 40 divided by 4. I get x equals 10. And if I do negative 18 minus 58, enter, equals, right? I get negative 76. Divide that by 4. I get negative 19. And so, since x is the years since 1990, I'm assuming we're going to exclude the negative one because this being a quadratic technically is like parabolic, and so yeah, that answer doesn't make sense in terms of this problem. Although it's possible with predator-prey models that you can get this little wavy function of populations, but we're just going to go with the positive one, x equals 10. And so what year does that represent? The distant future, the year 2000. The year 2000. That was a Flight of the Conchords reference there, by the way. All right, and so, yeah, if you have a function and you know an output and you're trying to figure out what input would give that to you, right, you can figure that out. Also, geographically speaking, 35 would have been about here. And then if I traced that down, right, I can see that graphically x equals 10 makes sense as well. All right, I'm going to call it. That's good enough for me. Have a good day, internet friends. Enjoy the quadratic formula. Go listen to some Pop Goes the Weasel. Adios.